Point 2, balancing chemical equations. Today we're going to talk about how to balance a chemical equation, and my goal is to give you all the tips and tricks that will help you in balancing chemical equations. So I've provided you with some skeleton equations here. We talked about writing the skeleton equations from word equations last time. And so now we're going to go from skeleton equations to balanced equations. So the first thing that you're going to want to do is you're going to want to draw a line underneath the yield arrow. And then you want to list the elements that are on each side of the arrow. So we have sulfur and oxygen on both sides. This is one thing that you should have the same elements on both sides. If you don't, you need to go back and check your formulas and make sure that you've correctly written your formulas. So sulfur and oxygen. We're going to count atoms like we practiced last time. We have 8 sulfur and we have 2 oxygen in our reactants. In our products, we have 1 sulfur and 3 oxygen. So we can see that the numbers of our atoms in the reactants is not equal to the number of our atoms in the products. So this is an unbalanced equation. We are going to change the coefficient in order to balance these out. So I have 8 sulfur here, and I have 1 here. We can only put a whole number for the coefficient, so I can't put anything here to get 1 sulfur. So we're going to start with sulfur. That means that I have to put an 8 for the coefficient here in order to get 8 sulfur. So 8 times the 1 sulfur that was there gives me 8. But that also is going to be multiplied by the 3 oxygen that are in sulfur trioxide. So 8 times 3 gives us 24 oxygen. So now sulfur is equal to each other, oxygen is not. Well, the only place that I can change oxygen is right here with O2. So we're going to put 12 for the coefficient in front of oxygen. 12 times 2 gives us 24 oxygen. So now these numbers equal this, it's balanced, and we're going to go back and fill in a 1 here. Sometimes you will see your chemical equations without the 1 for the coefficient, just like when we write our formulas, we don't write the 1s in. I'm going to ask you to go ahead and write in that 1, and that's going to signify to me that you believe you've balanced the equation completely and you didn't just abandon ship halfway through. So one of my first tips is that you always want to try to save oxygen, O2, for last. In this one, it kind of just worked out because we needed to work with sulfur first, and then we could go back and do oxygen. But if it's not as evident, try to do oxygen last. So on our next equation, we have aluminum reacting with iron 2 nitride to form aluminum nitride and iron. So we're going to count our atoms on each side. We have aluminum, iron, and nitrogen, and then we have aluminum, iron, and nitrogen. Here's something else that I do. Instead of writing them in the order that they come in on each side of the yield arrow, I write them in the same order on both the reactant side and the product side, so I can easily look back and forth to see if I've balanced it or not. So aluminum, we have 1 aluminum in our reactants. We have 3 iron and 2 nitrogen. In our products, we have 1 aluminum, 1 nitrogen, and 1 iron. So again, there's nothing that I can multiply by iron or nitrogen over here to get 1. So that means we need to first look at this side. Well, we can look at iron first. We need 3 of those. So 3 times the 1 iron gives us the 3 iron we need. And then we need 2 nitrogen. This is the only place I can change nitrogen, so we're going to put a 2 in front of aluminum nitride. That's going to give me 2 aluminum and 2 nitrogen. Well, now iron and nitrogen are equal, but aluminum is not equal. So we're going to put a 2 in front of aluminum on the reactant side, the only place we can change it. Now everything is equal. Go back and fill in with a 1. And now we have a balanced chemical equation. To start off with, I skipped over one thing briefly. It asks you, a chemical equation is balanced when the number of reactant atoms is equal to the number of product atoms. So again, a chemical equation is balanced when the number of reactant atoms is equal to the number of product atoms. And this is showing the law of conservation of mass, stating that matter cannot be created nor destroyed, and so we have the same numbers on both sides. All right. Hopefully you're getting the hang of this. I'm going to have you pause the video and go ahead and try these next two on your own. Welcome back. So I've went ahead and I've written the different elements here that we have on each side of our yield arrow. We're going to go ahead and count them. Calcium, we have 1. Hydrogen, we have 2. And oxygen, we have 1. Over here, we have 1 calcium. We have 2 hydrogen in calcium hydroxide and 2 in our hydrogen gas. So that gives us a total of 4. And then in oxygen, we have 2 in our calcium hydroxide. So the only thing that is equal is our calcium. So we need to look at our hydrogen and our oxygen. So on the last slide, we started going over to the products to start. Well, here, we're going to start over in the reactants because that's where we need more of our hydrogen and oxygen. So to get 4 hydrogen, we're going to put 2 for the coefficient in front of H2O. 2 times the 2 hydrogen that is there is 4. 2 times the 1 oxygen is 2. So now everything is equal. We're going to go back and fill in with 1s. Then we have hydrogen reacting with nitrogen to form ammonia, NH3. So we have 2 hydrogen and 2 nitrogen in our reactants. We have 3 hydrogen in our products and 1 nitrogen. Okay, so again, if we look at this, well, we have 2 hydrogen over here, we have 3 over here. Is there anything that I can multiply by the 2 to get 3? No. Is there anything I can multiply by the 3 to get 2? That's a whole number. No. Okay, so now, what do you think that we're going to do? We're going to look for the least common multiple between these, which would be 6. So that's what we're going to want to do. We want to put a 3 here, so that gives us our 6 hydrogen. And then we're going to want to put a 2 here. That gives us 2 nitrogen and 6 hydrogen. So now everything's equal. We're going to put a 1 in front of nitrogen. The next tip that I want to give you is count polyatomic ions as a group if they are intact on both sides of the arrow. So your polyatomics from your polyatomic list on the back of your periodic table, those are a group of atoms that act as a unit. So if they are together on both sides of the yield arrow, we can count them together. So we have silver, and then we have nitrate. Well, we have nitrate in our reactants. We also have it in our products, so we can count that as 1 unit versus counting the nitrogen and oxygen independently. And then we have potassium, and then we have phosphate. Well, we have phosphate in our reactants, and we have it in our products. So we can count that as 1 unit. So we have 1 silver and 1 nitrate in our reactants. We have 3 potassium and 1 phosphate. Over here, silver, nitrate, potassium, and phosphate. Okay. So we have 3 silver, 1 nitrate, 1 potassium, and 1 phosphate. Okay, so my silver and my potassium are unequal. Well, we can start either with potassium or silver. I'm going to start with silver. We need 3 silver, so we're going to put 3 in front of silver nitrate. That's going to give us our 3 silver, but that's also going to give us 3 nitrate. So now silver are equal, but potassium and nitrate are not equal. So we're going to need to change potassium nitrate in order to get our 3s over there. Not everything is equal. We're going to go back and fill in with 1s. In our next chemical equation, we have aluminum, we have lead, and we have nitrate. Well, nitrate is on both sides, so we can count that as 1. So we have 1 aluminum, 1 lead, and 2 nitrate. In our products, we have 1 aluminum, we have 1 lead, and we have 3 nitrate. So everything is equal except for our nitrate. Again, there's nothing I can multiply by 2 to get 3, and nothing I can multiply by 3 to get 2. So we're looking at the least common multiple, which is going to be 6. So we need to put a 3 here. That's going to give us 3 lead and 6 nitrate. And then over here, we are going to put a 2 to give us 2 aluminum and 6 nitrate. So now our nitrate are equal, but our aluminum and our lead are unequal. Well, I can change my aluminum here, put a 2 there. That's going to give me 2 aluminum. And then I need 3 lead, so we're going to put a 3 in front of lead to get our 3 lead. And now it is balanced. My next trick is, if you're stuck, try doubling the first compound. When you double the first compound, so this means that you're stuck, you've tried something, it's not working, and so you're going to go back and you're going to double the first one. Usually when you're going to double, you're going to have a hydrocarbon. Not always, but a lot of times this is the case. And there's other cases where you will double besides a hydrocarbon. A hydrocarbon just means that you have some number of carbon bonded to some number of hydrogen. You may also have some number of carbon bonded to some number of hydrogen and some number of oxygen. That is a hydrocarbon. So if you've tried something and it's not working out, go back and double that first compound. The other tip that I have here for you is water typically, not always, but typically needs to have an even coefficient. So we have CH4 reacting with oxygen to produce carbon dioxide and water. Carbon, hydrogen, and oxygen are on both sides of our chemical equation. So we're going to count our atoms. We have 1 carbon, we have 4 hydrogen, and we have 2 oxygen. In our products, we have 1 carbon, 2 hydrogen, and 2 oxygen and CO2, 1 in H2O. So we have 3. Okay, so remember I said save oxygen for last. So we're not going to look at this first. We're going to look at hydrogen. Well, we have 4 here, 2 here. So we're going to put a 2 for our coefficient in front of H2O, which is going to give us our 4 hydrogen. And it's going to give us 2 oxygen in H2O plus the 2 in CO2 for a total of 4. So now carbon and hydrogen are equal, but oxygen is unequal. If I put a 2 here, then that gives me my 4 that I need. and everything is equal, so we're going to go back and we're going to fill in with ones. In our next chemical equation, again, we have carbon, hydrogen, and oxygen. In our reactants, we have 6 carbon, we have 14 hydrogen, and we have 2 oxygen. In our products, we have 1 carbon, 2 hydrogen, and 3 oxygen. Okay. So if we look here at hydrogen, if you wanted to stay in the same place for hydrogen, we have 14 and we have 2. So if we put 7 for coefficient in front of H2O, that's going to give us our 14 hydrogen. It's going to give us 7 oxygen here and 2 here. So that is going to be a total of 9. And then our carbon has 6. So we need 6 times CO2 to give us 6 carbon. That's going to give us 12 oxygen plus the 7 here is, again, is 19. Well, there's nothing that I can multiply by O2. The only place I can change my oxygen and my reactants to get 19. So this would be one of those places where you're stuck. So you're going to want to go back, erase, which if you haven't been doing this in pencil, you probably are going to want to. Erase, and then we're going to try to double our first compound. So that's going to give us 12 carbon. 2 times 14 is 28 hydrogen. So now, if I need 12 carbon, put 12 in front of CO2 to get my 12 carbon. 12 times 2 is 24 oxygen there, plus the 1 in H2O is 25. 28 hydrogen, so we need to put 14 in front of H2O to get our 28 hydrogen. 14 times 1 oxygen is 14. So now we have 14 plus the 24 that we had over here in our CO2, 14, 24. That gives us a total of 38. So now, if we divide 38 by 2 to get our coefficient here, you should get 19. 19 times 2 gives us 38. And now we have a balanced chemical equation. So, my final tips on balancing is the number of each atom must be equal on the products and reactant side of the equation. You're going to want to balance common atoms last, such as oxygen, O2, and hydrogen, if possible. Do that. Balance your polyatomic ions as possible. We talked about that. It has to be on both sides of your chemical equation. You want to add whole numbers as your coefficients. You can't use fractions, and you do not change the formulas of the compounds. So don't just say, oh, I must have not written it correctly, and change it. It has to be the balanced formula for your ionic compounds, using the prefixes for your covalent compounds, and using your diatomic formulas for your diatomic molecules. So that's all that I have on balancing. Notice today I gave you all these skeleton equations. This is pretty much the only time that you're going to be given those. You're going to be expected to go from a word equation to a skeleton equation and then add in the balancing. That's what our next lesson is going to talk about. Thanks for stopping by. Have a great day.